Hey guys, welcome back to another Swift programming logic tutorial, and in this tutorial I'm going to be talking about binary search, what it is and why it's a lot more efficient than linear search, which I've already covered in the previous tutorial. So binary search is obviously another type of search, but basically the difference between this and what am I looking for? I'm looking for the YouTube's folder, which is right there. And basically binary search is different from linear search. So in linear search, I just realized I've created the wrong project. Okay, let me just do this again real quick. I don't want SwiftUI, I want the storyboard one, so I just do binary search demo like that. Sorry for this inconvenience, and we'll just close this. Okay, so basically in binary search all you do is you split the list in half every time and check if the value you're looking for is bigger than the middle or smaller than the middle, and depending on that you choose the left side or the right side. So it's actually very simple to code in Swift. Now what we're going to do is create a new function, binary search, and we're going to take a list of ints and also the number we're looking for, which will just be an int, and we're going to return an int, which this is going to be the index of num. So the first thing we need to do is we need to get the first index and the last index of a list, and this is going to help us split it in half and get the middle number. So if I do var first index is equal to 0, since that's always the first index of a list, and then var last index, and this is just going to be list.count minus 1, since that's how you get the last index. Now what we do is we just go into a while true loop, and we'll just repeat this until we get the item. You could do this a little bit differently if you didn't know if the number was in the list, but let's just assume it is. So once you've done that, in this while true loop you're going to have 3 if statements, but first we need to do is get the middle number. So let middle index is equal to, and we just do first index plus last index divided by 2, and this will give us so for list.count was 3, that means the first index would be 0, the last index would return 2 since it's 3, and then if you add that and then divide by 2, it'll give you 1. If it were an odd number, so if there were 4 in a list, it would give first index 0, last index 3. If you add them together and divide them, you get 1.5. But I think Swift will take the lower one or the upper one, I don't actually remember, but it doesn't matter as long as it's consistent, it's fine, and it is, since we're using Swift for all of these. And then we just get the middle value from that. So let middle value is equal to list middle index, like so. Now we can have our 3 if statements. So the first thing we check is we check if the middle value is bigger than the thing. Oops, sorry, I thought I said it. So if the middle value is bigger than the number we're looking for, then what we do is we just set the last index is equal to the middle index minus 1, since if this middle value is bigger than the number we're looking for, that must mean that the number we're looking for is in the left side of a list, and to get left side of a list we just need to get last index minus the middle index. So if this middle index was, let's just say this list was 3, then it would return the middle value as, if list.count was 3, then it would return the middle value as 1. Or wait, actually I should probably make it bigger. So if the list.count was 5, it would return the middle value as being 2. And then if we were looking for the first element in that list, then it would go here and it will split that in 2, and it will give us a list of 2 elements, and then we can just look for it in there. Okay, the second if else statement is we're going to create a else if middle value is smaller than number, and this means that we actually need to get the right side of a list, so we change the first index instead. So first index is equal to middle index plus 1, and finally we just check if the middle value is equal to middle value. Oh, I've got a middle index here, should be value there. Middle value is equal to the number. We don't actually need the else if, we could just do else, but it's better to write it out so that you get what it's talking about. And then what we can do is we can just return middle index, and we can break this loop so the app doesn't crash. If we run this now, we should see, oh, why are there 2 errors? Oh, this. Well, that's not an issue. Let me just see if I can change that real quick. So if I just go here and then change that to that, if that should soon work now. Oh, what's happened? That's weird. Okay, yeah, there we go. So I think that solves the issue. Okay, yep, there we go. Anyway, moving on. So you can see code after that, so we should probably actually break that. We break the list there, then outside of this while loop, oh, actually we should create these in here. So what I'll do is create them out here, and then I'll just add them in here as well. Alright, so now we can access them everywhere, and outside of this while loop we'll just return the middle index like that. Alright, so this is actually all we need to do for binary search. And now if we were to use this function, so let's just say I want to print binary search, let's give a list, so let's start basic, so 1, 2, 4, 5, and we wanted to find a number 2. Now the list has to be in order, because otherwise if you split it in half you wouldn't know if it was greater than or equal to, because or greater than or smaller than, because the value could be anywhere. So it has to be in order. It doesn't matter what order as long as the signs correspond to what you're doing, but best if it's ascending order. So once you've done that, let's just see if our function works. Okay, and it gives us 1, which is the index of 2. So now let's give it a odd number, 5, 6, and let's say we want the number 6. Let's see if this works. So basically it gives us 4, so 0, 1, 2, 3, 4. So basically how this works is number is 6, so the first middle number it gets is 4, then it splits the list into half, and this is the half which we're looking for, so it will take that, then it will get the middle number again, and I don't know if it rounds up or down, but if it rounds down then it will see that 5 is smaller than 6, so it will make this one list, and then it will just give it. We can actually print this by printing list, and then if we do how would I do? So I'll do first index and last index, and oh, how do I get a substring? I think I've forgotten. Is it like that? How do I get the substring? Okay, well that's fine. If that's not gonna work, then I guess I could just print them separately and we'll get the same idea. So if I just do last index and first index like that, we can see every time. So like this, if we're looking for 6, this is the first list, then it splits into this, and then finally it just gives us this, and then this is the index at which 6 is located. So yeah, that's how you create a binary search in Swift. Thanks for watching, and I'll see you guys in a future tutorial. Bye!